Alrighty, so today we're going to use what we learned yesterday about exponential functions to talk about a new type of function called logarithmic, okay? And we are going to discover a little bit about logarithmic functions and then kind of generalize about them using what we know about exponential. So I want you to start in this first table by filling out the table of values and then plotting the parent function to the x. So it's exactly what we did yesterday. Go ahead and fill your table of values up and plot your graph. You should be able to do this table of values without looking up here. All right, where's the asymptote on this graph? Okay. And we know this is exponential. What's the domain? Okay, and what's the range? Okay, if you have a different color, you might want to grab it. If you need to borrow one, you may quietly go grab one. What I want you to do in table 2 is I want you to find the inverse of those points. How do we do that? Yeah, just flip the x and the y. All right, so we're going to flip the x and the y. So all right, so we've just flipped our x's and y's, and now we're going to plot those points.
So you do this in a different color?
Yeah, I would recommend doing this in a different color. Good, because okay, in our original graph, as our y values got closer and closer to 0 but never hit, right? Well, this is the inverse. We flipped the x and y. So what are the x values going to do?
Closer and closer to 0.
Good, get closer and closer to 0 but never hit. So we have an asymptote at x equals 0. Okay, so we already said that these two graphs are inverses. What is an inverse graphically? Good, a reflection over the line y equals x. So if you want to kind of just sketch in y equals x to see how this is reflected, okay, but this is a reflection over the line y equals x. What is the domain of our new graph? And what's the range? How does that relate to our original graph? Yeah, they're flipped. They're switched, which makes sense, right? Because we're switching our x and our y values. Okay? The equation for this graph is f of x equals log log base 2. You write 2 as a subscript of x. And then x is back on the line with log. Okay?
Where's the base though? Oh, that just right.
This is read log base 2 of x. Okay? So for right now, you're gonna think of log functions as inverses of exponential functions. That's how we're gonna come up with the graphs. Okay? Starting when we get back from spring break, we will dive into logs a little bit more. We'll explore their properties, learn how to evaluate them, and then you'll be able to start graphing them without having to think of the exponential graph first. Okay? But for now, you're just thinking of them as inverses of an exponential. All right? So, the inverse of any exponential function is a logarithmic function. Logarithmic. Okay? The inverse of y equals 2 to the x was the function log base 2 of x that we just talked about up there. If we had the function y equals 3 to the x, the inverse would have been y equals log base 3 of x. Okay, don't flip the page quite yet. Okay, couple notes to graph log functions right now. You're going to find the exponential values or points and then find the inverse. So just like exponential functions had lots of different parent functions, they depended on the base, so do log functions. They all depend on the base. But there are a couple things that every log parent function has in common. Where is the asymptote in every log parent function? X equals 0. It's a vertical asymptote at x equals 0. What point do you think is going to be on every log graph? 1, 0. Because we know 0, 1 is on every exponential parent function. So the inverse of that is 1, 0. So we know that we're going to have the point 1, 0 on every parent function graph. Everyone okay? All right, let's plot some other parent functions. All right, so we have the equation f of x equals log base 3 of x. That log function is the inverse of what exponential function? Good. So we're going to come up with that table of values first. Then we're going to find the inverse of those values to plot our log graph. So 3 to the negative 2 power, 1/9. 3 to the negative first, 3 to the 0 power. 3 to the first is 3, and 3 squared is 9. All right, now take the inverse of each of those points for our log function.
We have to graph both.
Okay, we're only going to graph the log function. We're just using the exponential to help us get the points. So go ahead and plot the values for your log function. Where's the asymptote? So hopefully you're starting to see the general shape of these log graphs, okay? What's the domain? Oh, sorry, no, not negative infinity to infinity. 0 to infinity. What's the range? Okay. Any questions about that one? Okay. Let's look at number 2. This is log base 1/3 of x. What is that the inverse of? One third to the power of x. Now, remember yesterday when we had a base that was 1/3, did our graph look the same? No, it went from growth to decay, right? A reflection. So we can imagine that there's going to be some sort of reflection here since we have a base of 1/3. Okay? Anytime you've got these bases that are fractions, something a little weird happens with your graph. So go ahead, even though there's not a table there, you can make yourself a little table. I'm going to fill out the easy x values first. 1/3 to the negative first power. 3. 1/3 to the negative 2 power. All right, and then flip your points. Let's find your inverse. Then go ahead and plot your graph. Don't forget to label your asymptote. Do you see how it was a reflection from our previous graph? Okay, a reflection across what axis?
X-axis.
The x-axis, okay? So that's something to keep in mind, that base, if it's a fraction, it's going to take your normal log shape and reflect it across the x-axis. What's the domain? 0 to infinity. And what's the range? Good. Any questions about that? All right. Go ahead and try number 3. You don't have to fill out that whole table, but give yourself an idea. Okay, maybe 3 or 4 points. Go ahead and try number 3. Make sure you don't forget your asymptote. What's your domain? Don't spray stuff in here.
I've got hand light.
Okay. Everyone okay with this?
Yeah.
All right. Here is your general form of log functions. Y equals A times log base B of x minus h plus k. I mean, it's not necessarily something you have to memorize because we've used stuff like this so much. We're just going to talk about transformations. All right, what does A do? What happens if A is negative?
Flip over X.
Good. Okay, B is not a transformation here. B is your base, which tells you your parent function. One special thing you need to note is if there's no B, there's no B value, it's implied that B is equal to 10. Okay? That reasoning is that we work in a log base 10 system. We have 10 numbers. Don't really like worry about that. You just need to know. Anytime you just see log, it's log base 10. Okay? All right, what does the H do? All right, so sorry, not C. Horizontal translation. What does the K do? Vertical translation. Okay, so just like with yesterday where I told you don't need to worry about it like too much, you just need to know the location. Right here in front of these parentheses, that's where you would put a horizontal stretch or compression. Remember, you're not going to really be asked to graph that. Really just, can you write the number in the equation, or can you look at an equation and tell me in words what's happening? Okay? Mm-hmm. All right, let's look at number 4. F of x equals log base 7 of x. That's our parent function. We want to translate that 2 units right, a horizontal stretch by a scale factor of 2, and a reflection across the x-axis. Okay, how do we do the reflection? Okay, so negative log base 7 of, okay. Well, first we're going to do the horizontal stretch. How do we do that? 1/2. Remember, horizontal stretch is always the opposite, so instead of 2, it's 1/2. And then a shift right 2 units. You should put it there. You should have both those parentheses. Okay? This thing that you are taking the log of, this is log base 7 of 1/2 times x minus 2. That 1/2 times x minus 2 is called the argument. It's what we take the log of. Okay? The thing we're taking the log of, 1/2 times x minus 2. Okay, so look at number 5. What is your parent function in number 5? All right, and let's list our transformations. What are we going to do? Okay, and up 1. Are either of those going to move our asymptote? Yeah, what's our original asymptote? X equals 0. So where's our new asymptote going to be? Okay, just like with exponential, always move your asymptotes first. Okay, and then think about your point 1, 0. Go right 3, up 1. And kind of just follow the shape of your log graph. If you want to go get more points from earlier in the notes, you can. But for right now, I'm just really concerned with the shape, the asymptote, and that 1 point. What's the domain? 3 to infinity. And what's the range? All right, let's look at 6. All right, what's the parent function? Okay, now let's do the log parent function. So log base 1/3 of x. Okay, look back in your notes. Get an idea of what that looks like. Look back. We already graphed log base 1/3. You see it's kind of that reflected one? All right, so you got to keep that in mind. So what are the transformations? And the vertical stretch, you should write it, you should think about it, but we're not really going to worry about it too much. Okay? Right 2, up 3. Where does your asymptote move?
2. Right.
Bless you. Okay, our point 1, 0. It's going right 2, up 3. Okay, if you want to kind of pull out your curve a little bit and make it look a little stretched, that's fine. But right now, I'm just concerned with the shape. And remember, it's that flipped shape if you look back at your parent function that we already graphed. If you're ever not sure, though, you can kind of back up a few steps, fill out a table or two, and figure out what's going on.
Can you go over y equals 0?
Yeah, your only asymptote is x equals 2.
Okay, so you can go over y.
Yeah. Okay. All right, let's talk about number 7. What's the parent function?
Y equals log base of 5.
Good. Of x. What are the transformations? Okay, we have a vertical compression by 1/5.
Down 5.
Okay, why is it down 5 and not right 5? Yeah, it's not in parentheses. It would have to be in parentheses to be right 5. So this is down 5. So go ahead and try and sketch that shape. Don't forget to draw in your asymptote. Does our asymptote move at all?
I have a question with vertical stretch. Like, why is that not applied to this?
because a vertical stretch or compression affects the y value, right? So if we multiplied our y value of 0 by 1/5, it doesn't change. But it does affect the other points. We're just not super concerned with them right now. As we kind of figure out how to evaluate log functions and stuff like that, then you're going to plug in at least one more point and work it out. Domain? Range? Any other questions? Okay, on your homework, just like on last night's homework, you do not necessarily need to fill out the whole table. Okay, fill out enough of it to give you an idea of what to do.